And today we will be looking at quadratic functions, and we find what is called the minimum and the maximum of the quadratic function. And we also learn a new way of writing a quadratic function. It's called the standard form. So let's begin. So here I have a quadratic function, ax squared plus bx plus c, and we request a is non-zero. Now, if a is a negative number, then the general shape of the quadratic will be pointing down in this fashion. If a is positive, points up. Okay, now when I say the minimum and maximum of a quadratic function, I mean these points, either at the top of this mountain or the bottom of this sort of valley. So when a is negative, that's the case where we have a maximum. If a is positive, then it's a function that gives us a minimum. Okay, so when the function has a maximum or a minimum, we are interested in the x and the y value for which the maximum or the minimum is obtained. Right, so as you can see on the graph, I'll just call them xm, ym. Now, one really easy way to do it is a formula here. The x value, where the max or the min is attained, is given by the following. Call it xm. It's given by negative b over 2a. Okay. Now again, this only is talking about quadratic functions, right? Not the maximum or minimum of any other type of function. So again, I'm talking about a function like this. The x value is given by negative b over 2a. Okay. And then to get the corresponding y value, the y value where the max or min is attained, which is called the max or min. So the y value is called the max or the min, depending if a is positive or negative, is found by plugging the x value in. So it's found by, oops, sorry about that, the wrong paper. Is found by plugging xm into the function f, right? Or we plug in xm into f and then we solve. So I'll give you an example now. Let's consider the function f of x equals, 2x squared plus 3x plus 1. First we find them. In this case, it will be a minimum because this number is positive, so the graph will look roughly like that. We will have a minimum somewhere. The x value for which the minimum is attained will be given by negative 3 over 2 times 2. So that's negative 3 over 4. So that's the x value for which the minimum is attained. Now we find the minimum value by plugging in this x value into the original function. So we plug in negative 3/4 into the original function, and then we get 2 times negative 3/4 squared plus 3 times negative 3/4 plus 1. And now we just crunch these numbers. So 2, 9 over 16 plus 3, negative 3 over 4. 1. Okay, so that's 18 over 16 plus negative 9 over 4 plus 1. Okay, clean this up a little more. That's 18 over 16, and then we have negative 9. But instead of a 4, how about we multiply a 4 to the top and bottom, so we have a 16 on the bottom now. And instead of 1, let us write 16 over 16, which is 1. Okay, so now it's 18 minus 9 times 4, 36, plus 16, all over 16. Okay. So let's see, what is that? 18 minus 36 plus 16 is negative 2 over 16, or negative 1, 8. Okay, so if we were to look at the graph of this, we would have negative 3 over 4 as our x value, negative 1, 8 as the minimum value. And the graph would look roughly like this. Okay. Now this point is the minimum, or another word we can use is the vertex. So the point negative 3, 4, negative 1, 8 is what is called the vertex. Okay, so this is the minimum value, this is the location of the minimum value. The entire point is what we call the vertex. Okay, so this is one method of finding the max-min or vertex function. And another thing we can notice here is, well, the domain of this original function is clearly all real numbers if you look at the graph. Right, all x values, we can plug in any x value to a quadratic equation. We could also find the range now that we know the minimum. The range is all the y values included in this graph. Looking at the graph, we can see the range of this is just starts at negative 1/8 and goes off to infinity. So the range is these y values included in the graph.
Look at this grilled cheese and mac.
I guess so. That is one method of doing this type of problem. We use this formula here. Now I'll give you another method, but before we learn the next method, you have to learn a new skill called completing the square. So completing the square. And this is best demonstrated through an example. So the goal is to write our quadratic equation in this form. We want to write a quadratic equation to look like this. Okay, so that is the goal, and I will show you how to do it through example. So let's start with, I don't know, a function like, say f of x is 2x squared plus x plus 3. Okay, if we wish to write it in this form here, so the first step is we need to factor out any number being multiplied to the squared term. So here we have a 2 times the squared term, so I need to pull that 2 out, squared, and then I'm left with half x here, okay, and a 3 outside, okay. Now, if we look at our goal, we want what's in the parentheses to be perfectly squared, a perfect square term. So I need to add a magic number here so that I could factor what's in this parentheses perfectly. Okay? And how we find that number is take this middle number and cut it in half and square it. So if I take 1/2 and I cut it in half and square the whole thing, I am left with 1/4 squared, which is 1/16. 1/16. So what I need to do is add 1/16 in here, but it was really 1/16 times 2. So to balance the equation out, I need to minus the same number. I added a number and then minused it, so it's like adding 0 to the function. It does not change the original function. Factor the equation. So now it factors perfectly as follows. Okay, so adding this magic number, I did have to minus it as well, but when I put this magic number in the parentheses, I was able to factor this perfectly. Okay, and now let us just clean this up a bit. 2x minus 1/4 squared. And now I will multiply 16 to the top and bottom of 3. And then C3 times 16 gives us 48. So we have the following. 48 minus 2 all over 16. 2x minus 4 squared plus 46 over 16. Okay, and now we did it. We wrote the equation as we wanted to. Now this is what we call, sorry about that, this is what we call the standard form of a quadratic equation. And the reason it is useful is the vertex is actually just given by these numbers. So if it's written in standard form, we can just read off the vertex quite easily. The vertex will be 1/4 and 46 over 16. So that is the benefit of standard form. But you do have to complete the square if you wish to write your function in standard form. Okay, so maybe I will give another example. Just hold on for 1 sec. Okay, so another example, just to get some more practice. Let's consider the following quadratic equation. Say f of x is 3x squared plus, let me do a 6x plus 1. Now if we wish to write this in standard notation, first we need to pull the 3 out of the terms with x in it. Okay, you could leave the 3 out, or the 1 outside of the parentheses. Now we need to add the magic number. The magic number is we cut that number in half and square it. So that's 1 squared, that is 1. So we add a 1 here, but we have to be careful. It was really 1 times 3. So to balance the equation out, we need to minus a 3, which means we added 3 to the equation, minus 3 to the equation. We did not change the equation. We just did some manipulation. Okay, now the parentheses will factor perfectly as x minus 1 squared, and then you have the minus 3 plus 1 outside. So now that it's written in the standard notation, we could already tell that the vertex is going to be given by 1, -2. Okay. So let's go a little further with this example. If we know the vertex is at 1, -2, we also know this will be a minimum because this number is positive, so the graph will be opening up. So the graph will look roughly like this. You have the minimum here, opens up there. Okay, so the minimum value will be -2, which happens at the location x equals 1. Clearly the domain of this will be all real numbers. And by looking at the graph, now that we know the minimum, we know that the range will be from -2 off to infinity. Okay, so those are the two methods we can use in this section. Again, we start with an equation. Start with an equation that looks like ax squared plus bx plus c, and we could either plug into this formula to find the x value of the vertex and then plug the x value into the function to find the y value. That will get you the vertex. Or you can complete the square to write your function in standard notation, which gives you a vertex at point hk. Okay, so that concludes today's lesson. Thank you all for watching.